In this problem, we have a roller coaster cart that begins at the top of a hill, then rolls down at the bottom of the hill, gaining a velocity of 25 meters per second. This problem asks for us to find how high the hill is using the given information. In order to solve this problem, it is important to understand conservation of energy. There are two types of energy featured in this problem: gravitational potential energy and kinetic energy. Throughout the entire problem, the gravitational potential energy and the kinetic energy at the same point must always be equal to a constant. Now let's look at the beginning of the problem, when the roller coaster starts at the top of the hill. At this point, we can assume that the roller coaster is not moving, so kinetic energy is equal to 0. But it is high above the ground, so it does have gravitational potential energy, which is equal to the mass of the cart times the acceleration due to gravity times the height of the cart, h, which is what we're looking for. At the bottom of the hill, we can assume that the cart is at ground level, so this means that the gravitational potential energy is now equal to 0. But the cart is moving at 25 meters per second, so now it has a kinetic energy equal to 1/2 times the mass of the cart times the velocity of the cart squared. If the total energy is to remain constant throughout the problem, and at the beginning there is no kinetic energy, there's only gravitational potential energy, then we could say that the total energy is equal to the gravitational potential energy at the top of the roller coaster. But at the bottom, where it has no gravitational potential energy and only kinetic energy, we could say that the total energy is also equal to the kinetic energy at the bottom of the roller coaster. Because total energy stays constant, this means that we can make gravitational potential energy at the top equal to the kinetic energy at the bottom. This means the mass of the cart times the acceleration due to gravity times the height that the cart is at, which is also how high the hill is equal to 1/2 times the mass of the cart times the velocity of the cart squared. Since mass is on both sides of the equal sign, we could cancel it. And if we rearrange the variables, we get h equals v squared over 2g, which is equal to 25 meters per second squared over 2 times 9.8 meters per second squared. This is equal to 31.9 meters, which is our answer.